AI Power Energy Optimization at Langara College. When we talk about climate change, we think of oil, industry, cars. There's something else, something all around us, buildings. Buildings are responsible for 13% of Canada's carbon emissions, nearly twice as much as the entire electricity sector and more than agriculture or heavy industry alone. Most of that comes from heating, cooling and ventilation, HVAC, present in classrooms, hospitals, offices, and the places we live and work every day. At Langara College, we want to contribute by understanding the data behind the HVAC systems we rely on. We turned to our own campus and focused on research on Building B, a complex structure, where 5 HVAC systems and 114 VAV units work constantly to heat and cool over 300 rooms in 3 levels. We extracted data from sensors in Building B and used it to create a heat map, helping us understand its internal dynamics. We developed a dashboard to identify anomalies like equipment consistently overheating or overcooling. With these insights, we trained a deep learning AI model using CNNs and LSTMs to predict the building's air demand. Using weather data, the model forecasts temperature 15 minutes ahead, enabling HVAC to anticipate demand instead of responding to it. Think of it this way. You walk into a sweltering room, you blast the AC at full power, causing the system to work harder than it needs to, wasting energy just to catch up. But what if the system already knew? It could cool the space gradually before you arrive, saving energy and improving comfort. These kinds of adjustments could cut energy use by 20% or more, bringing us one step closer to a more efficient, low-carbon future. One building at a time, we're turning climate action into data-driven action.